is or more popularly known as dot product, which we have already learned in semester 1. If you're given two vectors, you can identify their scalar product or dot product. And scalar product, to bear in mind, is always a value. Okay, it's always a value. So A dot B, more popularly known as dot product, there's another name to it, which is scalar product. It's simply modulus A of the vector A and modulus of vector B multiplied by cos theta. Right? So you can also use this formula to actually find angle between two vectors. Okay, so theta is angle between the positive directions of vector A and vector B. Please take note that B cos theta is the magnitude of the projection of B on A, which is shown in this diagram. So because of the 90 degrees here, all right, and the theta value over here, so if you have a vector B, and obviously this side of the triangle will be modulus B multiplied by cos theta. This is using the basic formula of how to identify cosine. All right, so cosine is adjacent over hypotenuse. Yeah, please recap back. Here we will visit a few more properties, which is the first one, A dot B. All right, so the dot has to be in the middle. Yeah, A dot B is scalar, as I explained just now. It's a scalar product, so most of the time it's a number, right? And if you need to find the dot product of two vectors, it will obviously be modulus A, which are same two vectors A, modulus A, because the angle between the two vectors is simply 0 because they are same. It's A over A, right? So there's no angle between. So cos 0 is always 1. So therefore, you can sum it up as modulus A times modulus A is obviously modulus A square. Okay. And if it's A dot B is the same as B dot A, because when you substitute in the formula, whether you write modulus A first or modulus B first, it is not going to make any difference. Okay. So you're just looking for magnitude. And when it comes to the commutative law again, so if it's a scalar product of B plus C is the same as the individual scalar product being added together. So A dot product B plus A dot product C. So it's the same as A dot product with B plus C. Okay. And next, I would just like to highlight as well, if your dot product is a 0, okay, this is your semester 1 content as well, and provided vector A and B is not 0, therefore A and B will be perpendicular. This is simply related to the cosine value. If you are given vectors A and B in component form, so when you need to identify the dot product, so this is how you identify the dot product. You multiply the component A1 with the B1, and then followed up by addition of A2 with B2 and A3 with B3. So this is how you identify the dot product given the vectors in component form. And then next, if you need to find cos theta, is simply because modulus A modulus B equals to modulus A modulus B cos theta, right, equals to A dot B, right? So when we rearrange this and make cos theta as the subject, so it will simply be, so cos theta will be A dot B over modulus A modulus B, which is shown in this slide. Okay, so we are just rearranging it from the scalar product formula that we learned in the previous slides. If you're given component form, this is the method how you actually determine the angle between the two